Okay. Is the slide visible to you now?
Yes, sir.
Okay. Thank you. So sorry for the delay. I mean, there were some issues. I mean, someone took over the control and I has to get it back. So I started a meeting again, scheduled a meeting again. Okay, so in this case, till in the last class, we have been looking into the concepts of quantitative forecasting. In quantitative forecasting, we saw what is single moving. We first saw about the smoothing methods. In smoothing methods, first I covered moving average. In moving average, again we covered single moving average method, double moving average method. Then we saw weighted moving average method. And in today's class, we will be looking into the next two models. One is called as the first model we are going to look into called as exponential smoothing. So what is this exponential smoothing? So this is the formula that is to forecast the demand. We are going to consider the demand for the previous period plus the error value. But in that we are going to give you a smoothing constant. Okay, you just understand that alpha value, what I have mentioned here, is the smoothing constant value. So this is a constant, and always it should be in the range of 0.1 to 0.3. Okay, we don't want to dig more deep into that why it is only 0.1 to 0.3, but it's a general thing. We are assuming that like in thermodynamics we used to assume a lot of things. So similarly, alpha is equal to alpha will be a smoothing, is called a smoothing constant, and its value will be in the range of 0.1 to 0.3 only. So 0.1 to 0.3 only. So just remember that if in your case, in your examination, if someone is giving the value more than alpha 0.4, then it's wrong. So it should be always in the range of 0.1 to 0.3. Okay, so you can note on this point, 0.1 to 0.3 only, it should be there. Okay, so sometimes it's also given in the range of 0 to less than 1, anywhere in the range of 0 to 1, but preferred range is 0.1 to 0.3. It can be 0 to 1, but the preferred value is 0.1 to 0.3. Okay, you just remember this point. So you can note down this formula. I'll wait for 1 or 2 minutes. So the exponential smoothing formula is ft is equal to ft minus 1 plus alpha into dt minus 1 minus ft minus 1. So please make a note down of this formula. That is the forecasted demand for the previous month plus alpha value into the actual demand that for the previous month minus the forecasted demand for the previous month. So that is the exponential smoothing formula. Same formula, you know the formula to calculate the error in forecasting. The same formula we are using here. I believe that you noted down this formula. So the same problem I'm taking here, the same problem, and here the alpha value or the exponential smoothing value is given as 0.3. There's the same problem we are taking. Yeah.
Can you show the formula 1 second, sir?
Yeah, you can note down. Okay.
Yes, sir. Yes, sir.
Okay. Thank you. So the same problem we are taking, and here I assume the alpha value, that is smoothing constant value. The alpha is called a smoothing constant. We are assuming that, I mean, it's given in the problem that it's 0.3. I told you it should be in the range of 0 to 1, but preferably it should be 0.1 to 0.3. So here in this case they are given as 0.3. So what we are going to do? It's very easy. Only you should use the 0.3 value more often. You will be using. So it's the same problem. You can look into my cursor. The same problem I have given here. Whatever the input data is given, I'm taking it as that was in rows, and here I have taken it as in columns. Time and demand. Okay, of course, the spelling of demand is wrong. Sorry, just now I'm noting it. Then the forecasted value. How I'm going to forecast. So the forecast. So exponential smoothing. I told you it's the forecasted demand for the last month. Okay, the forecasted demand for the last month is 600, because in this case we are going to assume whatever sales we made in the last month as the forecasted demand, because we don't have any forecasted value. So we are assuming in this case the forecasted demand will be the previous month demand only. So that's why it's going to be 600 plus alpha value is given as 0.3 in the problem, and dt minus 1 is 600 and ft minus 1 also 600, because here d, that is the actual demand and the forecasted demand values are the same, because we don't have the forecasted value for the previous month. That's why we are assuming both the forecasted demand value and the actual demand value as 600 for the previous month. That's why again I got 600 as same. But in the next case, the actual demand is 628. The forecasted demand is 600. The forecasted demand is 600. So for the next case, the forecasted demand is 600. The actual demand is 628. That's why 600 plus 0.3 into 628 minus 600, which is giving you 608.4. Okay. So next is again for this value. So here the forecasted demand will be 608 and the actual demand will be 670. Okay. Are you able to understand this?
So how is 6
Yes.
FT minus 1608.4, how is it changing?
Sagittarius is just fell of you.
Can you please repeat?
So I didn't get the value of how 608.4 we got out of 600. The previous values were 600, 600, and then we got 608.4.
Yeah, that's why you listen to me. Again, I'm repeating. So the first case we are calculating for the second month. So the second month we don't have the any forecasted value. The data is not available. Okay, here the data is not available. The forecasted demand data is not available. So what I'm doing I'm taking for the second stage. So for the second stage, I'm considering the forecasted demand as 600. Also, the actual demand what happened in the first month is 600. So that's why I'm using the forecasted demand as 600 and the actual demand also as 600. So 600 plus alpha value was given in the problem as 0.3. I'm using that 0.3 here, and the actual demand also 600 and the forecasted demand was also 600. That's why 600 plus 0.3 into 600 minus 600, which I'm getting as only 600. So that value only I substituted here. Again for 608, in this second month, what happens is the forecasted demand will be 600, the actual demand will be 628. So that's why 600, the actual demand, plus 0.3, the actual demand of 628,
Okay, sir. Okay,
minus
sir, got it.
the forecasted demand. Okay. The next case of 627, how I got it? The actual demand is 670. The forecasted demand, 670. The forecasted demand is 608. So 608 plus 0.3 into 670 minus 608. I'm getting 626. Okay. You got it?
Yes, yes, sir. Thank you, sir.
So that's how I calculated all the forecasted values, and I found that for the 12th month it is coming at 785. Okay. Should I repeat? Are you able to understand?
This is.
Yes, sir.
Okay. Thank you. So in that case, shall I proceed to the next problem? With your permission, if you are able to understand. Otherwise, I can wait for 2 minutes. If anyone is not able to understand, I'll be happy to answer them again.
Sir, could you explain how to get FT minus 1 is 600 again?
For the first case, sir?
First case, sir, F2.
Yeah. F2. Sir, you listen carefully. That's what I'm telling. In this case, when I wanted to calculate the forecasted demand for the second month, I am not able to. I don't have the data for the previous month, right? I don't have the forecasted demand for the previous month, correct?
Correct, sir.
Okay, so what I'm doing, I'm taking the actual demand for the first month as the actual demand is 600. I'm also taking the forecasted demand as also the 600. I'm assuming both the forecasted demand and the actual demand of the first month is 600.
Okay, sir.
That's why I'm substituting the forecasted demand as 600 and the actual demand is also 600.
Okay, sir. Got it, sir.
Okay, are you clear?
Yes, sir. Got it.
Okay. Still, if anyone is not able to understand, again I can repeat.
So, so you told that for 608.4 we have to write the next biggest value. So it should be 609.
That should have been 609. Okay, you understood the concept, right? Okay.
Yes,
So
yes.
okay, you can correct it. Okay, 609. It can be 609. Okay, but you check it. The next problem it's 626.8. I assumed at 627. Okay.
Yes, sir.
Okay. Got it. So any doubts here?
No, sir.
Okay, thank you. So we have completed one more problem also. So with this note, we will move to the next problem with the same spirit. So the next one, what we are going to see is called as linear regression analysis. So what is this linear regression analysis? It's very, very simple. What you used to draw a lot of graphs for your fluid mechanics lab, thermal engineering lab exercises, right? And you will find the slope of the curve, right? So that is called as that is a simple regression, linear regression problem. So what we are trying to do is we are trying to fit all the data into a single line, right? So here what happens, it is like with respect to something is going to change, like the supply and demand. So what we are doing in this case, it's going to be supply and demand. So what we are doing with respect to one variable, how the other variable is changing, with respect to one variable, how the other variable is changing, that is what we are trying to plot here. Okay, so if you're using only one, there will be always one dependent value and another one is called independent value, or one independent variable we call as variable, one dependent variable and another independent variable. So we are always going to compare this. So if you're using only one dependent and one independent, we call them a simple linear regression problem. If you're using more number of independent values, then we call as multiple regression method or multiple regression problem. But in your case, we are going to study only about the simple linear regression method. Okay, so with this, so you should not be knowing this already. So the dependent variable d is equal to a plus bx, you call it as x. The independent variable we always call it as x. So d equal to a plus bx. So a we call as the intercept and b we call as the slope. This is simple, like what you have plotted in your lab exercises. Okay, so are you able to understand the dependent variable d is equal to a plus b into independent variable. Independent variable is x, so a is intercept and b is slope. You can note down this formula. You can note down this formula, please. Okay, as I told you, there is going to be one dependent value, another one is going to be the independent variable. So dependent variable and independent variable. Okay, I am mentioning as value. Sorry, it's variable. Okay, can we move?
Yes, sir.
Yes.
Yes, sir.
Okay. Okay. So next, so here in this, you look at the graph. It's being plotted body weight versus the height in the graph. So here the y-axis I have equal to a plus bx. Okay. So and we have to find the slope of the curve. B is a slope. In the last problem, here I told you B is a slope. So how to plot this slope? To plot this slope, I have the formula, right? Summation of xy minus n into summation of n into y bar into x bar divided by summation of x square minus n into x bar square. Okay, so this is how we find the normally we find the slope of the line by using this formula. Next, how to find this all y intercept? A equal to, so a equal to y bar minus b in this b, the b what we calculated, b into x bar, and y is equal to a plus bx. We are removing the bar, so out this equation y equal to a plus bx. Okay, this x is in the time, y is the demand, and a is a constant and b is a coefficient variable of x. So x bar is the mean value and y is bar is the mean value of y. Okay, so this is how we are going to do the problem. So you can note down these three formulas, that is b equal to summation of xy minus n into y bar into x bar divided by summation of x square minus n into x bar square. Okay, so and a equal to y bar minus b x bar and y equal to a plus b into x, dot product of x. Please note down these formulas so that we can proceed to the problem. Okay, so have you noted down the formulas?
Yes, sir.
Okay.
Sir, just a minute.
Yeah, please.
Yes, sir, done.
Okay, thank you. So now we know the formula to calculate B, A, Y. Okay, so now we look into the problem. So this, and we are asking to calculate the demand for the 14th week. Just note on this problem. I am asking you to calculate the demand for the 14th week. Okay. Here what I'm doing, this is very simple. This is very simple. It may sound something like your uh, like some of your old problems. So just listen here. Just some of your statistics problems, right? So here, so it is like this. So of course, this is statistics. So week I'm taking as x because that is the variable. Then demand the second variable as y. So here one for the first month. So whatever data is given to me, I have assumed like this. I have assumed like this. I have assumed I have taken it in the x and y. So the whatever variable whatever the data I have given here, I am taking it as x and y. The week as x and demand as y. So next I have to find out in the form. If you are not remembering this how to do this, you can just check the formulas. If you know the formulas, it will be easy. So we need summation of xy. Please listen to me. We need the summation of xy to calculate b. So xy I will multiply. So how I'm going to do? Just multiply x and y. Just multiply x and y. In this case, the x is going to be the time period. So 1 into 420 as 420, 2 into 420 as 900, 3 into 460 as 1380. Like I am calculating for till the 12th month. Are you able to understand this? This step, the first step, how we calculated xy.
Yes, sir.
Just multiplying these two columns, I'm getting the third column. Okay, just multiplying the first two columns, I'm getting the third column. Because in this formula I have to substitute the summation of xy. The summation of xy. So I'm calculating the all. I'm adding up all these xy values, and I found out that the summation of xy as 42570. So I'm substituting 42570. Next, we need n value. N is the time period. So n we have 12. I am putting 12. Next I have to calculate y bar value. Okay, and how to calculate that y bar value is, where y bar means mean. You know that mean value. That's why we are calculating some y bar value is what? Summation of all this y divided by n. So n, I'm multiplying again by 12. Then x bar value, summation of all this x value is 78. So 78 divided by 12, I'm putting this here. Okay, have you got how you calculate x bar and y bar? X bar is equal to summation of y divided by n. X bar is what? Summation of all x values divided by n. Here n, in this problem n is 12 because the time period, the total time period is in 12 weeks. So I'm taking it as 12. Okay, have you got this first step?
Yes, sir.
Okay.
Yes, sir.
Next, x square. X square is this. So I have to calculate x summation of x square. So I'm just squaring up the first column. 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16. Like that I'm calculating till the 12 square. 12 square is 144. Then I will get x square values. Then but I need summation of x square. So I'm summing up all the x square values and I'm getting the value of 650. Okay, you got this? How we got this? How we got this 650 value? The x square value, the summation of x square value. I have just squared the first column and I have summed up all the x square values, and it's coming as summation of x square value is coming as 650. So that's how I got 650. Okay, then we know the value of n as 12 into x bar square, x bar square. So x bar is what? 78 divided by 12. 78 divided by 12, again I'm squaring it up. So when I solve this equation, so when after substituting this, when I solve this, I get the b value as 17.23. You have any doubt till this?
So you haven't included these slides in the ones which you uploaded in the Google Class.
Sir, I have uploaded in Google VTop, sir. You can check in VTop. Okay, that are my old slides. Okay, I will slowly replace one by one. Meanwhile, I'm uploading daily. I mean, after completing one module, I'm uploading it on the VTop. You can check your VTop. For this class, I already uploaded. Okay.
Okay, thank you, sir.
Okay. So here the B value is 17.23. Do you have any doubt how we calculated B value? If then I can repeat it. So no one is having any doubt. Okay.
No, sir.
Okay, super. Then I believe that everyone understood. Okay, so B value is 17.23 because we just I have calculated using this formula. Okay, then we know the formula of A as y bar minus x b x bar. Okay, A bar is what? Summation of all y values, that is 6170 divided by 12. 6170 divided by 12 minus b value we know 17.23. I'm substituting here, and x bar value is what? 78 divided by 12. So I'm substituting that value. So y bar value, if I divide this, I'll get 514.1667 minus 17.23, and the x bar value, if I divide this, I'll get 6.5. So when I substitute all the values of y bar and x bar and b in this, I'm getting the value of a as 402.17. Okay, but we know the regression equation is y equal to a plus bx. Y equal to a plus bx. We know y as y equal to a plus bx. So from the formula y equal to a plus bx, excuse me, y equal to a plus bx, I'm substituting. Okay, I'm substituting this here. A plus bx. A value is 402.17 plus b value is 17.23 into x. This I have mentioned as small x. This is not x bar or x value. This x is the variable which we don't know and for which we have to calculate. So in this problem, we are given find an equation of the regression line and estimate the demand for the 14th week. Because for the 14th week, we don't know. Okay, we don't know for the demand for the 14th week, the independent variable, we don't know. 14th week, what is the demand, we don't know. So I'm in this place of Vx, I'm substituting that 14. Okay, I'm substituting that 14 and I got the value as for the 14th week, the demand is what? 643.39, that is 644 items. Okay, you have any doubt? So in this case, the small x, what I mentioned here is what? The demand, what is for the 14th week, what is the demand? So if you want to calculate the demand for the 14th week or for the week, what is requested in your problem, that what the problem is demanding, for that you have to substitute here. Okay, in this case, I need the demand for the 14th week. If I need 13th week, I'll put 13 here. For the 15th week, I can put 15 here. Okay, so are you able to understand this? If you have any doubt, I can answer you.
Yes, sir. In that x, we will put 14, right?
Yeah.
Okay, sir.
In this x, we should put 14 because in this problem, it is 14th week. Okay, they're asking us to predict the demand for the forecast the demand for the 14th week. That's why I'm putting 14. Okay, if in your problem they are asking any other thing, you can add that one.
Okay, sir. Got it.
Okay, super. So if you have any doubt, I can wait for you. So everyone is clear. I can wait 1 or 2 minutes for you to if you have any questions in this forecasting, you can ask me. Let's take it very slowly because this is some problems are there. So this will be there in your cat 1 also. So I can wait for some time.
Do we should round up for A and B value?
I don't want, sir. You can only the final value you can round off, sir. Don't round off A and B value. That's a nice question. Don't round off the A and B value. You round off only the last demand value what is getting. So in this case, it is 643.39. You can round it off to 644. Okay.
Okay.
So the next higher value. Yeah. Okay. So any doubt? Any more? Do you have any? Yeah. Please.
Sir, the values of A and B have to be restricted to 2 decimals.
You can restrict to 2 decimals or 3 decimals. That's enough. Don't like here since I use some Excel sheets to calculate this. It's it's going like 1667. Don't make it so tedious. Just
Okay,
round it up to 2 values or 3 values. That's more than enough.
Okay, sir, fine.
Generally, I use an Excel sheet to calculate this, so my work becomes easy, right? That's why. That's why it's giving us 1667. I can understand 0.1667. Okay. So are you able to understand? Should I wait? I hope you are clear with how you are calculating X bar and Y bar. Okay, the summation of all X values divided by the time period again, that will give you X bar, and the summation of all demand value, that is Y values, divided by the number of time period will give you X Y bar. Okay, so you know how to calculate. You should understand how to calculate Y bar and X bar. That is also very important. So X Y will be given. You have to calculate X and Y value is given. So you should multiply X and Y. Then you have to calculate X square. Okay. Then you have to take summation of all these things. Then divided by number of periods. Then you'll get all the answers. Okay. So I believe that is easy. Only these 2 things you should remember: multiplication and division. Okay. So is that clear? So shall we move on?
Yes, sir.
Okay. So with this, what we are doing is we have completed the first module successfully by online method. Okay. So we will be moving to the next next unit. Okay. So next unit, I got around like some 15 minutes more. So I think I can continue with the next module. So as I told you, we have completed this in the we saw about macroeconomics, microeconomics, demand and supply, and the determinants of supply and demand. Then we also see elasticity of demand and types of elasticity of demand. In this forecasting, we saw the short-term forecasting and long-term forecasting. We saw about qualitative forecasting techniques. We learned a lot of 5 problems in quantitative forecasting, like single moving average method, double moving average method, weighted moving average method, exponential smoothing, and simple linear regression problem. So we also saw all these things. So with this, we are closing the first module. Okay, so with your permission, now we will move on to the next module, the second module. The second module is, so just a second, hold on a second. Okay. So what we will do is, as a second module, I like to you are having your okay. That's the next module. I like to teach you about productivity. Okay, that is the third module for you. Actually, that is going to be the third module for you. But I like to teach you the third module as second module. Okay. So are you ready? Let's go to the second module. Are you ready?
Yes, sir.
Yes, sir.
Okay.
Yes,
You are not able to look into my slides, right?
No, sir.
No, sir.
Okay. Done. Okay, so now we are going to move into the next module. That is industrial engineering and management. In this subject, we are going to the next module that is called as productivity. Okay, in this module, we will be discussing about what is production, what are the types of production, and what is the definition of production, and we are going to see the factors affecting the production, and what are the things which will improve your, what are the activities we should do to improve the productivity, and then how we are going to measure the productivity, and with some case studies we'll be solving solving one or two problems here, and we'll understand what is productivity. Okay, so let's go with understanding what is productivity. So, okay, before I ask this question, start this module, can anyone explain me what is the difference between production and manufacturing? What is production and what is manufacturing? Have you ever thought of these words, production and manufacturing? Most of the time we take it as a single word, right? Hello? You can unmute yourself, or otherwise.
Manufacturing is the creation of new parts, whereas production can be an assembly of the manufactured parts as well.
No. Okay, that's what we are going to discuss in the next 10 minutes. Okay, so you see, production we call it as is the process and methods used to transform tangible inputs, that is raw materials, semi-finished goods, sub-assemblies, and intangible intangible inputs into goods and services. There can be both, input is going to be both tangible and intangible. Okay, ideas, information, knowledge in case of a software industry. In case of in a product oriented industry, it's going to be raw materials, semi-finished goods, and sub-assemblies into goods or services. Okay, that's what it's going to be, a product based or it's going to be service based. We are going to transform these things. Transform means like we are going to add value to these products, tangible and intangible inputs, and we are going to come out with some goods and services. So that's what we call as production. Then what is manufacturing, correct? Manufacturing is the production. You understand this? Manufacturing is the production. Manufacturing is the production of merchandise for use or sale using labor, men, material, and machines. Triple M, I told you, men, material, and machines. Using some tools, chemical and biological processing or formulation. So it can be of anything, but understand, manufacturing is the production. Manufacturing is the production. Okay, so then what's the difference? Both sound a bit similar, right? But what is the difference? In production, the raw material is often bought from outside. It's not bought from outside. It's not bought from outside. Most of the times, the company is owning it and they're converting that into the final product. Okay, so say for example, we saw agriculture is a production activity. That's why we call agriculture as a production activity. We don't call agriculture as manufacturing, because the farmer is owning the farm and he is having the raw material with himself, he is producing it. So that's what we call the produce. That's the best example for production. So when you have the raw material and if you're able to produce something, then that is called as production. But in this modern world, even sometimes the production people, they're forced to take the raw, because the raw material is not available. They have to take it from outside sometimes. Okay, again it depends upon the quantity of raw materials what they take from outside. So its production is what? Just converting inputs to outputs. Just converting inputs to outputs. So that is the narrow term. But manufacturing, if I say manufacturing, the company procures raw material from outside. It's like the company, like a smelting unit, or it can be any company. It will take the raw materials from outside the company and it will manufacture the product. Okay, so manufacturing is the process of converting raw material into finished goods by using various machines, energy. All these things will be used, and that is like general, like so. Because manufacturing is production, so they are going to convert raw material into finished product. And manufacturing is a broader term. That's what we tell. Every type of production is manufacturing, but every manufacturing is not a production. Okay, so manufacturing is a bigger term and production is a small term. In a manufacturing company, production can happen. Okay, that's the meaning. So in a manufacturing company, the production can happen. Okay, so if I say any big company, the production is going to happen inside. A garment company, the production of garments is going to happen. Manufacturing is a bigger term, production is a smaller term. Okay, production means just conversion of raw material into finished goods. Just remember this. Production means conversion of raw material into finished goods. So that is raw materials in sense. I mean raw material, semi-finished goods, sub-assemblies like that. Raw material means here I mean finished goods, semi-finished goods, or the raw material itself. So there are three categories, right? Raw material, semi-finished goods, or sub-assemblies, or some even some parts. So these are these which is going to get into some big component for getting assembled. So production is the conversion of raw material into finished goods. Manufacturing is how this all this process is happening. So that we call as a manufacturing in a bigger term. Hope I'm clear.
Yes, sir.
Okay, thank you. So we will see what is a production system. Normally, what happens in production? So now I told you production means what? Conversion of raw materials into finished goods. The raw material will be in tangible and intangible. Okay, so using some tangible and intangible inputs, we are going to make some goods and services, goods or services. Okay, so which the customer will feel more economic, or which the customer will be happy paying, and he feels that some value is there in the product and is ready to buy the product for the value what the product is going to possess. Okay, I told you generally we classify inputs as 3M. Okay, 3M: men, material, and machine. So there is one more M. Let's take it now. From now on, we'll take it as 4M: men, material, machine, and money. Okay, the four inputs. We are going to give this these are the four basic requirements or the inputs required for any manufacturing activity. So that is what men, material, and machine. When I give these four things to some subject these four things to some activity, that activity can be a transformation activity or the production activity. The transformation is what? The production, conversion process, conversion of raw material into finished good products. So if is subjected to production activity, then the output will be what? Some goods or services. So after that, we have a feedback loop. If something goes wrong, we are going to correct again and again. Okay, so that's all. So I give four inputs: men, material, machine, and money into some production activity. That way, I'm able to get some outputs. That can be a goods, a physical product, or a service-oriented industry. Means I'll get some service out of that. So if I'm able to get something out of the production activity by giving some intangible and tangible inputs, if I'm going to get some goods and services, then then the system is called as a production system. Okay, are you clear? Is the definition of production systems clear to you?
Yes, sir.
Okay, good. So what are the types of production, right? So now I call it the three ways of production. So the first, the production happens by disintegration. The second, the production can happen by integration, disintegrating, integrating, and production by service. Okay, in case of disintegration, the best example I could discuss is breaking down a component. Breaking down a component, production by disintegration, like breaking down a component, like this crude oil. You know this. You have studied this fractional destinational column in your chemistry long back in your school days. So that is production by disintegration. I'm breaking the crude oil into different components using the fractional destination column in different stages. I get different components. Otherwise, imagine imagine a sculptor making a idol out of stone. Is carving the stones, right, and is making a big idol. So that is production by disintegration. Then what is production by integration? Production by integration, assembling. All your assembling activity can be considered as production by integration. You are assembling 2 3 components. Even cooking is called as production by integration. Okay, even cooking we call as production by integration. We are not removing anything, we're just adding everything, mixing it, and making some food, right? So production by integration. So that's that. And 3D printing can be the best example for production by integration. And the next case is called as production by service. You have a bike service center, your mobile service center, your service center for all your electronic products. So all these things can be called as production by service. Or even hospitals, schools, colleges, they all come under production by service. They do some service, and because of that, they are doing some production activity. So that is called as productive activity. So that's what we call as that is also as production by service. So now we know the three ways of production. One is production by integration, production by disintegration, production by service. Okay, are you clear with this?
Yes, sir.
Okay, good. So
So,
yeah,
so can I take the attendance of this? Or I'm having another class.
yeah. Sir, you have 15 minutes time to break from one class to another class. I know when to start and stop. Okay, next time I don't want you to repeat this. You have 3 more minutes to close this class. It's only 10:47. If you don't want, you leave the classroom. I don't mind.